I welcome you all in Igneous Pathology class. In my last video, we had discussed identification of igneous rocks and I gave a few pics of different rock types. To continue, today we will further discuss the different samples of igneous rocks that you will identify in hand specimen. Now, the first sample is in front of you. This is granite. This sample, this is your granite, right? Now, in the granite, you all know that granite is in plutonic rock and has your minerals as quartz and orthoclase as essential mineral. So you can very well see the minerals. This is your orthoclase, flash red, right? This is your quartz, and these dark one, these are the mafic minerals, biotite and your alkali amphibole, because it has been identified or it has been chemically diagnosed as an alkali granite, means your Na2 and K2 they are more than Al2O3, because in feldspars Na2 and K2O are utilized in formation of feldspar with equal amount of Al2O3. But if they are excess, means Na2 and K2 is more than your Al2O3, then it is called the alkali granite, and these Na2O K2 alkalis they will form some alkali mineral. Nevertheless, this is for you in simple words. This is an sample of your granite, and you can very well see the grain size coarse grained rock with flash red. This is flash red feldspars and your quartz. This quartz and the black ones as amphiboles and your biotite. So this sample, I think it is not difficult for you to identify if you are given in laboratory. Now then same, it is also feldspar. This one here, the feldspar they are white. These feldspar they are white. Flash, these are not flash red. These are white, and they are little bit altered. Whereas your quartz is having vitreous luster and is transparent and it is extremely white. Whereas the feldspars they are altered, and they, you can say this sample again is of an rock granite, but these two granites are different in the sense the earlier I showed that was a flash red feldspar, this is white feldspars, and this distinction you can very well notice in even Rajasthan. Your Jalore granite is flash pink color, flash red, that is feldspar granite, whereas your Sivana granite is in appearance similar to this one. They are not pink colored, they are white colored feldspars. So these two samples I showed you is they are of the feldspars. Again, this is a sample of a granite. You can very well identify same way. Now this sample also resembles to your different, you can say the field samples of this are different of the granites. Now this is your rock diorite. Now diorite, once we say diorite, means it has your quartz less than 5% and Na plagioclase, means feldspar nature is your plagioclase feldspar, and that too your Na means, once we say plagioclase, the albite to anorthite end, albite, oleoclase, andesine, labradorite, bitonite, anorthite. So this albite is anorthite, albite is your Na end, whereas your anorthite is Ca end. So these are Na plagioclase dominantly and amphibole. Now this is your amphibole, this is black one, this is amphibole, and the white ones these are the your plagioclase, and that your Na dominating means your either albite, oleoclase, andesine, such this nature, and this is again extremely coarse grained. So this sample is of your diorite, and you can see further it how they will appear. This is again diorite, this is diorite. Same way, it depends upon model composition of your plagioclase and your amphibole. Now there is a range in which they can, this here this relatively your amphiboles they are more relatively. Now this is a very common and very important igneous rock. This is gabbro. Now you can very well see in the gabbro. Gabbro, you all know, is a plutonic rock, right? And the mineral composition is your clinopyroxenes, mean diapside or augite, plus your Ca plagioclase, means your labradorite to bitonite as in plagioclase feldspars, means Ca feldspars. So what you notice here, these are your feldspars. These are plagioclase feldspars, that too you see labradorite, biotonites as feldspars. And these black ones, these are your pyroxenes, they are clinopyroxenes, your diapside, augite. So this is again texturally it is coarse grained, it is a plutonic rock, and as far as mineral composition is concerned, these you can see identify. You all know that silicate minerals broadly they are divided into two, that is the felsic and mafic. In this you can very well observe the felsic mineral as your plagioclase, that too your calcic plagioclase, and mafic as your that clinopyroxenes, and almost they are in equal amount in the sample. Particularly the various variants of this you can further notice. This is again a gabbro with little larger grain size compared to the earlier one. This is relatively large size of your, because once we say coarse grain means their diameter is more than 5 millimeter. Now the upper limit is not defined, so this sample compared to the earlier one, it is little coarser in that sense. Mineral composition is the same. Now this is a sample of an your volcanic rock. This is rhyolite. Now in rhyolite, you all know that the mineral composition is same as that of your granite, but the texture you cannot identify in hand specimen the different minerals, right? So this is, but it is all it's clear that is a leucocratic on that basis, and the field relations also, that base it is identified as your rhyolite. So the pink is bit buff colored, you can say white colored, this, and this is very small grains, means the grain size is naturally less than 1 millimeter, that cannot be distinguished in hand specimen. So this is an rhyolite. Now moving to next, this is your very well used, this is andesite porphyry. Porphyry, why? Because there are phenocrysts. These are the phenocrysts of the mafic minerals. This is larger size grains. These they are embedded in the ground mass. So this phenocrysts are of your mafic, and the mineral composition as such, when we say andesite, it is again in a volcanic rock. So as such andesite, because andesite is the volcanic equivalent of diorite, which you would see, means they are the your Na plagioclase plus your amphiboles. So these phenocrysts they are of the amphiboles, and this ground mass is of your plagioclase, Na plagioclase feldspars. This is the porphyritic nature. Similarly, you can see the nature. This is the porphyritic rhyolite or rhyolite porphyry. These terms I will explain in one of my texture when we will take up the igneous textures. Here the phenocryst in this sample, this is the these are the phenocrysts, right? These are the phenocrysts. These for the your orthoclase feldspar. These are phenocrysts, and the ground mass is quartzo-feldspathic. Because the number of phenocrysts are relatively less, that's which we had added rhyolite porphyry. Had they been more than, you can say, 50%, or you say 5 to 50%, it would have been called porphyritic rhyolite. So the phenocrysts are less, you can say, then it will be called the rhyolite porphyry, because the majority portion of the rock is in the fine grained form, and these are the are the phenocryst of the orthoclase. So as such we will call this rock as the rhyolite porphyry, similar to that what we say the andesite porphyry. Now this is an again very interesting rock, and it is this one, this sample you can see here. This is your basalt, right? This is the basalt, and basalt you all know the equivalent of your volcanic equivalent of your gabbro, and the mineral composition as such of the your basalt is your pyroxenes, means your clinopyroxene, diapside augite, and your plagioclase is your laboratory composition, means more calcic in that sense, calcium rich plagioclase you can say it. So this is your because it doesn't has any phenocryst, as such we can't say basalt porphyry. We simply say that the basalt, it is a fine grained rock, and you all know it is the volcanic equivalent of your gabbro. Here you can see this basalt. This in this sample, uh, in this sample, these are the large. These are the phenocrysts of your calcic feldspars, right? So this is, you can say, is very clear that the ground mass is of your ground mass. This is of your mafic mineral, that is pyroxenes, whereas the phenocrysts are of your plagioclase. So this resembles to your, you can say, basalt porphyry or porphyritic basalt in that sense, because it has porphyritic texture. Now this is a granodiorite. Granodiorite means it has quartz as well as your plagioclase feldspar and little bit mafic minerals. So these, what this is our felsic minerals. Now these felsic, you know, the light colored these minerals, they are your either quartz or plagioclase. Now plagioclase is latch shape that you can distinguish with keen observation in hand specimen, and quartz, relatively the grains are polyhedral in the shape and they are white, whereas the feldspar, the plagioclase, sometimes when they are altered they look turbid or muddy type, right? So this is your granodiorite, quite resemblance to that your earlier what you seen in that the granite, because in the granite it was orthoclase, whereas in granodiorite it is plagioclase. Granite is quartz plus orthoclase, whereas this plagioclase is quartz, this granodiorite is quartz plus plagioclase. And nature of the plagioclase feldspar is really, the color is white. If it is altered, it looks turbid, and it has a little bit latch shape. It is not polyhedral in outline. So this is obsidian. I showed yesterday also the obsidian. It is a glass, in the volcanic glass you can say. We cannot identify the minerals. It is formed under rapid cooling conditions when it has glassy nature or zero grain size. The nature of the minerals, they are not crystallized. There is no crystallization, means zero grain size. This is the amorphous of the glassy material in it. Then if you further, this is cyanide. Once we say cyanide, means this rock has your orthoclase. Now dominantly this mineral, this is your orthoclase. This is orthoclase, and absence of quartz. You can see all this is our orthoclase, self 1-2 grain of your quartz, and these are the mafic minerals. So if you move from quartz, from granite to granodiorite, right, then to cyanide. So means cyanide means your, it will have dominantly your orthoclase, and there will be quartz up to say 5% only, and the mafic mineral will relatively increase that compared to that of your granodiorite or granite. So these are the mafic minerals. Again, this is coarse grain. This is a plutonic rock. You all know it, cyanite, right? Then this is a sample of your ultramafic rock, dunite. Dunite means it has more than 90% as olivine. This is all total. This is the olivine, right? Now more than 90% composition of this is in dunite. Once we say pyroxenite is again ultramafic rock, it has 50% pyroxene, 50% olivine. But if you pyroxenite in that, other words, if it has more than 90% olivine, then it is a dunite rock. So it is an ultramafic rock having more than 90% olivine, and you can identify the olivine in this. This is slightly greenish in that, or say the olivine mafic mineral, right? So this is an olivine. So in the few samples, I think you get acquainted. The difference you can notice that if it is a plutonic rock, it is extremely coarse grain. Grains are almost of equal size. But if there is a difference in the grain size, few are large, then we'll add the term porphyry before either the name of the plutonic or volcanic rock, if there is a difference in the grain sizes. Then if the rock is glassy, then I have shown you the samples of your obsidian, scoria yesterday also, and you can very well observe the difference in the grain size. So like this, I think you have an experience now of different rock types, of igneous rock types, and if you are given in the laboratory, you should be in a position to identify. If you just like, if you identify a person somewhere, if you meet him somewhere, and if if you meet again somewhere, then naturally you try to recall, yes, this is so and so. Similarly, this experience, if you see the samples, you observe the samples in any specimen, though there are the physical properties of the different minerals, with that help you can take, but the experience also works. So try to, what I mean to say that after this lockdown, when there will be practical classes. There are number of samples in the museum as well in the pathology lab. You just observe them. We'll arrange them for you. But right now with these pictures, I think the things are the different rock names, and you should have a perception of different rock types. Thank you very much. See you next class.